I was the former coordinator of this eTEACHER project. Then it was my colleague Gloria Calleja who took that role, but now she is on maternity leave, and so again I am taking over the coordination. So the goal of this conference is to discuss about how can we improve energy behavior through ICT tools. That was the main focus of our eTEACHER project. And so we would like to present our findings and development. And we also would like to take the chance to discuss about the synergies and similarities with some of our sister projects that you can see there. The NATCH project, AAA Reno, Feedback, NRG to Peers, and eBalance Plus. Okay, so to start, I would appreciate if you can switch off your microphones and camera, and then turn them off, both microphones and camera, whenever you want to, when you need to talk. And also please use the chat box to ask questions to the speaker or to make comments. And also this webinar is going to be recorded, and you will get the recording in your inbox so that you can watch later on also and share with your stakeholders. So in here you can see the speakers that we have today. We have the picture of the speakers from the eTEACHER project. Then we also have speakers from our sister project. So from CEMOSA, it will be myself with the introduction and conducting the conference. My colleague Jacobo will explain about the integration methodology. Carmina will explain about the lesson learned and the final results of the project. Ashley is our social scientist, and she will be dealing with all the issues that we have done to implement this end-user behavioral change methodology. Then we have our software developers, because eTEACHER is a toolbox. And so we have Nicolas from Ascora, Hervé from Fraunhofer, Alina from Gragnum, and Florian from IFM. And the last three are the pilot coordinator. So we have Francisco from Agenet, Paula from IPE, and Andrew from Nottingham City Council. And obviously we will have one representative of our sister project, NATCH, AAA, Reno, Feedback, NRG to Peers, and eBalance Plus. So this is the agenda that we have today. So this is the opening, and then following, we will have a brief presentation from our sister projects, and then I will make an introduction to this eTEACHER project, and we will also launch a poll with 2 questions. And then we will explain, after the poll, we will start with showing you the development of our eTEACHER project. We will start with the findings from our social scientists and our engaging methodology. Then we will go through the different tools that we have developed, carried by our tools developers. Then we can have 10 minutes to grab a coffee or stretch your legs. And after that, our colleague Jacobo from CEMOSA will explain the methodology for the integration of the different system and tools in any type of building. Then we will see how it has been going in the pilots, and we will have the case of our Spanish and Romanian pilot. After that, we will have the point of view of our policymakers. So they will be explaining how we can incentivize behavioral change from the policy perspective. Then Carmina or Maria will conclude with the lesson learned from the eTEACHER project and the conclusion, and then we will launch again the poll to see if you have changed your mind from the beginning to the end of the session. After that, we will have a round table with our sister project, and and then we will have the question and answer section. So please do not hesitate to include your question whenever you want in the chatbot, and we will go through all of them at the end of this session. So now I give the floor to our sister project. So maybe Simona Doca can now introduce the AAA Reno project, and she can share her screen.
Let me turn on my camera so that you can also see me for a while, and I'll be sharing my screen. I'm not sure if you want me to present the AAA Reno project and the Energy to Peers project as well, so that I can do it together, or I can just leave it for after, like you prefer.
We can start. Well, I mean, you can go one after the other. That's fine. So Simona will be introducing the AAA Reno and Energy to Peers. So you have the 2 sessions in a row.
Yeah, perfect. Thank you lots. So, well, first of all, let me thank you for inviting us to this final conference. I know how important this can be to share your results, but also to create a sort of common ground, also to connect with some sister projects. So that's the importance of our collaborative effort in Horizon 2020 projects. So just a small introduction to myself. My name is Simona Doca. I am the project coordinator of AAA Reno and Energy to Peers. I work at Hurricane Consulting Engineers, and among these projects, we also coordinate other Horizon 2020 projects. So we are involved in 13 at the moment. So we're somehow acquainted with this environment for a while. So just a small introduction to the 2 projects, starting from AAA Reno. We had been in contact with the eTEACHER project at the very early stage, so we can find indeed some elements of similarities, but we also wanted to stress some innovative and unique approach of the project. AAA Reno stands for attractive, acceptable, and affordable deep renovation. And this is going to be facilitated by a consumers-oriented and a performance evidence-based approach. Why we're doing this, of course, we all know, because in order to achieve the objective sets by 2030 and 2050, effective actions must be taken, and a user-centered approach are indeed the key to enable this change. So AAA Reno started in May 2018. It should have been done by April 2021, but we asked for a small extension of 6 months because our platform was indeed not finally integrated like probably you're going to present today. When introducing ICT-based solutions, engaging users, it is always complicated to integrate the different parts. So one of our encounter barrier was indeed the multiple integration of the tools into one single platform. So attractiveness, affordability, and acceptability for AAA Reno means creating creating solutions that are more attractive, appealing for homeowners. Mainly the renovation journey is a very complex journey, and with the AAA Reno platform and the AAA Reno tools, we are aiming to introduce this gamified elements that engage users, understands what is best for them, what are their needs, with several tools. Just to be more specific, I introduce here a slide about what are our tools and how this connect to the ICT developments. So basically, Readiness, as I said, adopted this user-centered approach for the validation and the development of three main tools. One is, our final result is the user-centered gamified platform, which is composed by different web apps, and I'm going to tell it a little bit more just right now. One of the key elements is a combined labeling scheme to provide clear evidence of the actual performance of the building before and after the renovation, also involving the user into this assessment, including the effects on health and well-being, and to reinforce all the gamified features that we included in the ICT platform. We decided to develop a board game, so a physical board game. This was something unique for us because we realized that despite all the work encountered and developed for the development of the ICT platform, the importance of reinforcing the connection with the user was paramount. So we started the development of what we call the energy transition game, which is basically a guide for players in their quest to find how to make an existing home a renovated home. So among all different options, the players can be, for instance, construction professionals, energy advisors, students, or homeowners. So with the game, we really can identify the different stakeholders playing in or enabling the renovation process per se. So in the game, you're challenged in several scenarios, and in order to choose the right measures and to learn about the different concepts, you can navigate among these different cards that we developed. And to enhance the playing experience, some real-world events are also added. For instance, unexpected subsidy or the possibility to get green mortgage. So the idea of the energy transition game is really to engage the users also offline, to increase their knowledge about the options on home renovations. And it is the way we constructed this is that we try to be as specific as possible, but also try to use a language that could be understood by a different level of knowledge. So the board game has been developed in English, but then has been translated in the national languages of our pilot sites. And it is possible to receive one of the board game. So if you're interested in playing with it, you can send an email to me, and we are able to print and ship the board game all over Europe. So another tool, which is indeed also the basis for the ICT platform that we are developing at the end, is the combined labeling scheme. This is probably one of the first and mostly inclusive labeling scheme for approved renovation works. It has two versions. One is the version for the homeowner, and one is the version for the expert. And indeed, this has been developed at first as an Excel file. And this Excel file for the assessment of the energy performance and the environmental quality and well-being of the occupants can be also downloaded for our Readiness website. But the interesting part is that and probably the most difficult has been the integration of the Excel into a automated web-based tool that could be used from the homeowners to immediately assess what the energy performance of their dwelling was, and to receive automated, simplified suggestions on what to take as action first. The Triple Reno combined labeling scheme is just one of the parts of different features included into the Triple Reno platform. This is a very complex platform that indeed asked us or required us to extend the project 6 months more, but it includes several tools. And here is just a collection of all of them, from the labeling wizard, which is indeed a wizard that allows homeowners to immediately label the state of health in the environmental quality of the homes. And the morphological design tool, which is one app that allows homeowners to very quickly design some renovation scenarios that are following a sort of renovation strategy. Everything it's very simple and in terms of communication and visual design.
Simona,
yeah,
I'm sorry, but you need to speed a little bit.
Yeah, of course.
I'm sorry, this is very interesting, but we know.
I'll try to.
Apologies.
This is just the last slide, of course.
Yeah.
Of course, if you want to know more, you can just send me an email and I'll get more information.
Yeah.
Okay, so this was basically it for the Triple Reno project. Very briefly, the Energy to Peers project is something that goes beyond the building level. So we're trying here to build a support platform to uptake energy communities in Europe. So this is something a little bit different in the sense that it's not just about building per se, but it's about how to engage users in energy communities. Of course, everything started from the concept of fair and inclusive energy transition from our commissioner. Why we're doing this? Well, one of the main obstacles in setting up effective energy communities is the user understanding and acceptance of collective actions, and the need of a clear guidance and education and support and methodology to support the practices within energy communities. Let me just go here. This is indeed one of the main results so far, and it's the Energy to Peers Readiness Level Framework. What we understood is that in order to support a successful uptake of energy communities, we have to, of course, assess how technological infrastructural readiness is there, which level of technological infrastructural readiness, organizational readiness, market readiness, but also, and most importantly, the user readiness under different perspectives. So with our group of anthropologists and social scientists, we're trying to build this support tool to understand, where to go and what are the steps needed to engage communities. Also there, we are developing the Energy to Peers platform that has different level of action, but basically will provide smart mechanisms such as, again, gamified features, and also use blockchain-based mechanisms to show data from at a community level to engage peer-to-peer transactions. Again, I don't want to take too much time. There are many other aspects. So again, also here, if you want to know more, just send me an email. Happy to connect after the Q&A session. Sorry for taking so long.
Yeah, thank you, Simona. Sorry, we need to keep the agenda, but very relevant. I think we will be in touch. So now it is the turn for the NAX project. So maybe Filipos Nax Nostopoulos can speak now. Hello,
Hello.
Filipos.
Thank you, Naomi. So share screen. Give me a moment.
Yeah, again, before you start, please try to cope with the timing. I mean,
Certainly.
it was supposed 2-3 slides, you have more, so please.
Can you see the presentation? I'm not sure it's visible.
Yes, it's visible.
Yeah.
Okay, all good. So thank you. Thank you for giving us the opportunity to present Nudge. I'll be very quick. So Nudge started actually last September 2020, and it will run for another 3 years. So we're, getting the first half of the project. This is the consortium. We are mostly research institutes. We have also a consumer association, university, two SMEs, a school, an energy cooperative, a utility. And what the project aims to do is to essentially systematically assess behavioral interventions so that we can be adding them to the policy making toolbox. We can skip that. So what is nudging? First of all, I think this will be discussed since it's the eTEACHER final conference after all, and you have touched upon nudging. But essentially, I would say that it's a way to motivate behavior without needing to rely on the traditional economic incentives or in-kind incentives and so on. Instead, nudging is based on social norms, social comparison, default options in specific applications and commands, or by reminding users of the potential consequences of their actions. So the project is now just finishing its pilot phase, where we had a very wide survey across Europe, almost all member states, to derive user profiling based on a number of psychological and contextual variables. We have also progressed to design nudging-based behavioral interventions. So there's a large list of them, as this one that you see here on the left, that pilots can use to apply to the people involved in the pilots. And now we are in the pilot development phase. The pilots have been developing for the past couple of months and will be ready to go online at the end of the summer. So in that sense, we have been installing smart meters and thermostats, and we've been creating the relevant apps and the dashboards and a central platform that will collect all the data. Now, as of September and for the next 2 years, all these pilots will be feeding in data to the central platform that will allow for more efficient data collection and monitoring. And based on a robust research framework, we will be able to assess the effectiveness of the specific behavioral interventions, nudging interventions through KPIs. Then all of this is packed together and offered as policy recommendations of how policymakers can be using nudging as an alternative or as actually as a complementary to incentives. And I'd like to close quickly with our pilots. So we have 5 pilots in 5 different countries: Croatia, Portugal, Greece, Germany, Belgium. We are mostly focused on the residential sector. It is targeting mostly electricity, but also natural gas. We look into EV charging and self-generating electricity from energy communities. We cover all age groups, from children that are going to school actually in Belgium up to the elderly. And we also look at things other than energy. So we look at comfort, health, indoor air quality, and so on. Now, the common thing across all these pilots is that participants are provided with tools that allow them to monitor and manage their energy use. These are being developed as new, or in a couple of pilots, these were pre-existing and being updated. They will also have digital interfaces, such as mobile phone applications or dashboards through which to look into their energy use and for us also to assess the effectiveness. And we're also looking at long-term behavior change in terms of energy efficiency. So that's the overview of the project. If you find this of potential interest, I would ask you to follow us on Twitter at nudgeh2020. You can also visit our website at nudgeproject.eu, where you can find much more about what I just briefly glanced over. And of course, please subscribe to our newsletter to be informed every 6 months or so about our updates. So I think that's all. Thank you again for the opportunity, and I'll give the floor back to you, Naomi. Thank you all.
Thank you, Philippe. This is very interesting, and thank you for keeping the timing. Thanks a lot. So now we will go to the feedback project presented by Felipe Suarez.
Can you see my screen now?
Yes, we can see it.
Okay. So if I put it this way, you can see it. It's better to keep it like this. Okay, so my name is Filipe Soares. I work at eTEACHER. It's a research institution in Porto, Portugal. And well, eTEACHER is a big institution, so we have several centers and we work in several areas. And for this case, I was working in multi-energy systems and energy efficiency, and so
Philippe,
Yeah.
sorry, Philippe. We are watching the very first slide, the one with the title of the eTEACHER.
Yes. I was just making a brief introduction.
Okay, that's fine.
Okay, but
Please,
we
keep the
started
time.
working. Yes.
Up with the timing.
Okay, and we started working in energy efficiency with the project Feedback, which is a project I think similar to the previous ones because they are from the same call. And as in the other projects, our main goal in Feedback was to promote, stimulate, and deliver energy efficiency through behavioral change. For that, we developed, I'm saying this we did in the past because the project started in 2017 and ended in April this year. So we are just preparing the final documentation for the commission. But we developed a lot of similar things. I think that others are slightly different. A wide set of applications from load disaggregation. We also developed an energy metering infrastructure, let's say. We also have consumer profiling and segmentation and even forecasting of load and production and baselines. And we did that because we wanted to give kind of the nudges, taking here the word from the previous project, to the users based on what could happen tomorrow. So we wanted to give these nudges ahead of what would happen during their day. So the challenge here, as in other projects, was to integrate everything. So this is just a slide to show you how we integrated the different applications. We had different servers, different databases. We had to integrate everything. But there was a very important thing. All the data stemmed from meters and sensors, meters for energy metering. And here I include electricity, gas, and water. And sensors for indoor air quality and comfort. So we were monitoring so temperature, humidity, luminosity, and CO2 concentration. Okay, so this was the basis of the data, and then we have profiling and segmentation. So data that we acquired from surveys that we did to the users. As the sensors were a very important thing here in the project, we needed several of them.
Felipe, sorry, you need to hurry up. Sorry.
Yes,
this was just 3 minutes presentation.
Okay, the sensors were very expensive, so we had to develop one. This was a sensor developed within Feedback. Okay, so and then we needed the front end with the users. And for the front end, we developed also a mobile application, iOS and Android, with let's say gamification elements. You can see here, for instance, the badges. And the application had a very interesting component, which was to raise awareness. So it was a little bit educational, with some videos that were also developed in feedback to teach people to how to save energy in different situations in the residential for residential buildings and offices and other types of buildings. And we showed the users some of the indicators that we were measuring, like temperature and humidity and other stuff. And there was competition and even team competitions. We don't have much time to explain further. You can find more on the website. Just to conclude, we had 3 demonstrators, one in Porto, one in Barcelona, and another in Lip in Germany. Different buildings, so offices in Portugal, public buildings in Spain, and houses in Germany. Okay, and this is the consortium.
Okay.
Okay, you have the website for more information. You have a very interesting video, so please watch it. And okay, this is my contact if you need further information.
Thank you, Felipe. We're going to ask all of you maybe to send the presentation so that we can upload with the recording and everything from the conference, so that everyone can watch more carefully. Thank you.
Okay.
So now we will give the floor to the eBalance Plus project, and it will be presented by our colleague Jared Kowalski. Please, Jared, the floor is yours.
Yes, hello.
Hello.
Good morning, everybody. I'm trying to show my screen. Okay, do you see my screen?
Yes.
Okay, my name is Jarek Kowalski. I'm a social researcher from National Information Processing Institute, Warsaw, Poland. We are a partner. We have a great pleasure and privilege to be a partner in eBalance Plus project, which is funded by European Union in Horizon 2020 funding program. It consists with 15 partners from 10 countries. You can see all the partners listed on the left of this slide. The main goal of the project is to release, to unlock, to increase the energy flexibility and make it available for distribution system operators and transmission system operators. We are working, the project is twofold, in fact. The one layer is technological layer. We are developing new solutions, new innovative technological solutions. We are working with technologies listed in the right side of this slide. For example, smart storage for buildings or bidirectional charging points in electric vehicles. We are also thinking about this system as a fractal-like. So the idea is to develop bi-directional and hierarchical communication at different domains. And found it and make it possible on negotiation-based algorithms. But we also see this whole issue, whole problem we are dealing with, not only pure technological, but we also perceive in this whole equation another layer. I mean social layer. So within all these technological domains, there is also additional domain of people with their own habits, way of thinking, approach for usage electricity, and some of the functionalities we are developing are automated and releasing this flexibility in a background, and it is not visible for the electric energy users, but some of them require some active participation from the people. For example, allowing withdrawing energy from the accumulator during vehicle to grid charging, or sometimes to postpone doing something to release the flexibility to the system. So we are in this layer, we put the user in the center, and we are trying to understand the users. So we use many different tools, co-creation workshop, interviews with stakeholders, quantitative surveys on national samples, to understand, to get deeper understanding of the motivation, drivers, and barriers which are behind the usage pattern of electric energy, and to build the engagement methodology to encourage people to active participation in our system. So we are thinking and we are looking in different areas. We are in the middle of the project, so but we plan to develop the application, which will be the maven between this technological layer and users. But we also, so we are very glad to be here to know something about a teacher project, which is very in some ways is similar to our way of thinking. But we also are thinking.
Jared, you need to speed up. Sorry.
Okay. The last two sentences.
Okay.
we also looking in behavioral economy and the works of Daniel Kahneman, Amos Tversky, and other scientists. So we see also the similarities with the Nudge project. So we are very glad to be here and now, and we are hope for a very fruitful discussion in the next quadrances, in the next parts of today meeting. Thank you very much. If you have any other questions, please contact me via email, or here are our digital sites where you can get more information. Thank you very much.
Thank you, Jarek. Okay, so now thank you very much for all this presentation from our sister project. They all share similarity with the eTEACHER, so we are happy to discuss with you all the common issues. Sorry, can you see my screen?
Yes.
Yes. Okay, so now we will start with the presentation of the eTEACHER findings, and this is it. Okay. So this is where we are in the agenda now. So I will introduce the eTEACHER project. So eTEACHER is an Horizon 2020 project. It started in October 2017, and it will be finishing today, in fact. So our consortium includes 12 organizations from 6 countries, and we have large enterprises such as Temosa, which is us, Granlum, and Laura Otero. We also have 3 SMEs, such as IFPE, Ascora, IFM, 2 non-profit enterprises, which are Steinbeck and ICE, 2 public bodies, which is Agenex and Nottingham City Council, and 1 research institute, which is from Hofer EAS, and 1 university, which is the Montfort University. So you can see where we are. And so now I will start with the eTEACHER project. So the mission of eTEACHER is to encourage and enable energy behavior change of building users in order to save energy and also to improve the comfort condition. And our vision, our going of way of doing that is by means of some behavioral change intervention facilitated through a set of empowered tools that allow the user to take informed decisions. So, so the final goal is to achieve a behavioral change, and we do that by means of ICT tools. We have 12 pilots building to demonstrate our technologies, and they are in 3 countries. So we have in Spain, we have 2 healthcare centers, 2 schools, 1 residential building, and 1 office building. In the United Kingdom, we have 1 school and 1 office building. And in Romania, we have 4 residential buildings. So as I said, the mission of eTEACHER is to enable a real building end user behavioral change. And the final goal is to save energy and to improve user well-being. So the challenge we have to tackle for this are the ones I'll explain. Firstly, and very relevant, eTEACHER solution need to be integrated with the monitoring and control system in the buildings, in the different type of buildings. And so in that regard, integration and interoperability is an issue. Secondly, we are dealing with a large variety of buildings. We have private buildings and public buildings and of different uses. We have schools, residential, office, healthcare center, and we need to cope with them all. And that means different technical equipment and different end user with different age, different culture, different education, and different purpose in the use of the building. And that is also a big challenge. Thirdly, we need to develop a system that is affordable. That was something that was mentioned before in our sister project. So both the monitoring system and the solution need to be cost effective. That is the only way that we can facilitate a real market penetration and make the tools that we do affordable to all, so that all of us, we achieve a real energy behavior change. And also, user behavior and motivation to change is very dependent on the role of the context. So, as mentioned before, we deal with a huge variety of end users, and we need to cope with them all. And finally, this is about saving energy, but still, we want to keep. We don't want to compromise comfort levels, so we need still to optimize user well-being. So in here you can see the eTEACHER concept. So eTEACHER is a set of empowered tools, and the boundaries of these tools are on the one side the building performance, and on the other side the user behavior. So our tools need to send information, need to receive information back and forward to the building on the one side and to the user behavior on the other side. And in the middle, we have our empowered tools. I guess you can see my screen, my mouse. Okay, so here you can see the empowered tools that we develop. On the side of the building, we have what we call the BACS add-ons, and on the side of the buildings, we have the end user solutions. So regarding the BACS add-ons, we have the universal BACS communication interface, which is our data management system. This is what allows, that facilitates the interchange of data in our system. Then we have the what if analysis, which are the tools to provide a recommendation in order to save energy, taking into account the building performance and the energy needs. We also have a tool for data processing to analyze the indoor conditions. And on the side of the user, we have the tools that are oriented toward providing information to the user. I mean, on this side, we have the tools in order to get information from the user and provide tailored advice. And in that regard, we have on the one side the energy efficiency and comfort advisor, and on the other side, we have all the tools to get end user feedback. So as I said, we have this tool. We have 2 types of tools. And then in the middle, you can see here the different ways that we have used to analyze or to try to change end user behavior. So these are the methodology that we have explored from the social scientist point of view. In that regard, we have been dealing with energy literacy, that is to say, how to increase the energy knowledge of the end user. We have used KPI gamification. We also have used energy visibility and bonus system. And so we have deployed this concept, and we have demonstrated it. And we have 12 pilots to demonstrate it in 3 countries. Overall, we have been involving around 5,000 people. And as I said, we have not only buildings in different countries, but also 4 building typologies: residential, office, education, and healthcare center. And so this is all for the presentation of the. Sorry, no, this is just my last slide in here. I just wanted to put the emphasis on how difficult it has been to cope with the huge variety of building with different equipment and different type of user. And in here you can see a glimpse of the different technical solution that we have been dealing with. So it has been really challenging, but we have managed to make our system integrate in. I mean, we have been able to integrate our system with the different system in the different building, and everything is interoperable. And so this is all for the moment. And now now we are going to launch a poll. Now we are going to launch a poll. I think that Veronica is going to show the question on the screen. And so we are going to present a couple of questions, and we would like you to quickly answer them. And then we will use this as a discussion for the final part of the session. So I don't know if you can see I cannot see the question, Veronica. I don't know if everyone else can see them.
Yes, I think so, because people are replying.
Okay. So the question, shall I? Well, you can already see the question, so please answer them. And then we will go to the next section. So.
Okay,
Please,
I will close the first question. I will open the second one. So please, if you still have to vote, vote now. Okay. Now I'm closing the first. Now I share the second. So please vote. Okay, thank you. I see that some of you are still voting, so I wait a few seconds more. I just remind you that we are showing the results of the poll. I mean, Noemi is showing the results of the poll at the end of this webinar. Okay, I'm going to close the poll in a couple of seconds. So who still has to vote, please vote now. Okay, done. So Noemi, you have the floor.
Okay, so now after this, I think we can start with the presentation of the different findings of the eTEACHER project. And we are going to start with the social scientist perspective through, I mean, from the analysis of the end user-centered design for this energy saving app. And so for that, our colleague, Dr. Ashley Morton from the Montfort University will make the presentation. Thank you, Ashley.
So I hope you can see my screen.
Yes, Ashley, we can. You can go ahead.
Brilliant, thank you. So hi and welcome. As Naomi introduced, I'm Dr. Ashley Morton, and I'm based at De Montfort University. And the DMU team was responsible for the initial eTEACHER Work Package 1, which was designed for behaviour change for energy end users, which encompassed social science insights to make recommendations towards the design of the eTEACHER tool. So today my presentation is focusing on user-centred design with energy-saving apps, and does it work? So why do we need a user-centred design approach? Well, as Katie Janda summed up perfectly, buildings don't use energy, people do. And it's been known for some time now that being able to target and change human behaviour in relation to energy consumption is a key factor in being able to achieve the sustained energy consumption reductions that we need. And in an ever increasing kind of digital environment, the need to successfully utilise ICT within energy efficiency interventions is never more prominent. So the use of ICT within energy interventions can aid the digitalisation of actions, improve information access to users, increase user awareness and harness potential energy savings. However, with the increased push to utilise ICT within energy efficiency interventions, we often focus on the technological benefits and potential energy savings rather than listening to the end user's needs. And as such, many ICT-based energy efficiency interventions fail to produce the impact expected, often resulting from user disengagement, a complex array of competing demands on the target users, and sometimes misaligned perceptions of the end user's willingness and understanding. So user-centred design and co-design methodologies allow for the end users to become part of designing a successful solution, which takes in consideration the context in which the ICT-based intervention is being implemented. And eTEACHER has adopted such a user-centred methodology approach right from the start of our project. But the real challenge was how to design an ICT-based solution or tool which could empower and engage a wide variety of end users from a range of different building typologies. So not only do we need to consider the building types, and Naomi introduced kind of the various buildings that we have in our sample. We've got residential buildings, schools, healthcare centres or offices. And we need to consider all of these, but also we need to consider the user type. So we've got owners, private tenants, teaching staff, students, medical professions, patients, office workers, building visitors, and the list goes on, each with their own different challenges. But we also need to consider the occupancy patterns of both the buildings and of the end users, the appliances being used and the frequency of this use, the energy systems within the buildings and how these are controlled, and whether all users actually have the agency or access to change any of these. And ultimately, we need to understand the motivations, the opportunities and the capability of those end users. So can one tool really fit all of these? Well, eTEACHER adopted the Enabling Change framework developed by Les Robinson as a foundation for our user-centred approach, which is an evidence-based approach drawing on both theory and practice to provide an accessible framework which develops behaviour change interventions. So the Enabling Change framework consists of two main planning levels. The programme level planning, which defines medium to long-term objectives for tackling the desired problem. So ideally kind of at the start of the project, and this was something that we did with kind of all of our project stakeholders to define what it is that eTEACHER was attempting to achieve and how we could do that, what existing knowledge base that we had. And then the project level planning, which is a foundation to design on the ground kind of projects and interventions which can engage target audiences and decision makers in actions aimed at then contributing towards that overall programme level objective. So for eTEACHER, this kind of project level planning related to understanding each of our pilot buildings in more depth, understanding the key actors that we could target within those buildings, but also identifying doable behaviour change given the individual building context and the user's capabilities, and then ensuring that the intervention that we designed and we implemented through our tool was enabling and supportive to the users. And at the heart of it was involving the end users from the start. So throughout the project, the end users were actively involved in providing feedback and helping to shape the overall eTEACHER tool. The Enabling Change Framework recommends ongoing kind of involvement and engagement of target users through the creation of a brains trust, which is described as an advisory group of target audience members and other supportive stakeholders. So for eTEACHER, this principle was applied through continued engagement and the use and creation of feedback forums. So the user-centred engagement that eTEACHER used throughout our project can actually be mapped against the British Design Council's double diamond design stages. So there's 4 main key stages around designing an effective solution. The first one being discover, where basically you question the challenge and research the needs within the environment that you've chosen. Define, where you align the user needs with the overall challenge or problem that you're trying to overcome. Develop, which is to identify possible solutions and testing those solutions, so that could be multiple different versions. And then deliver, so that's selecting your best solution and implementing it within a chosen environment. So throughout all of those kind of 4 stages, we can map our eTEACHER user-centred methodology against it, where we used or we ensured that the end users were involved in all of these kind of stages and giving us feedback on how we could refine the tool further. So during the discovery phase, this aligned well with the first kind of 3 steps of the Enabling Change framework. And the key objectives were to understand more about the user's needs and to identify the challenges which eTEACHER could tackle within each of the individual pilot buildings. So this involved understanding the context of all the pilot buildings through site visits, questionnaires, interactive workshops with both end users within the buildings, but also with project stakeholders as well. And then the data collected helped us to move into our kind of defined stage of kind of our methodology, where we could align the user needs and behavioural change opportunities to the eTEACHER's overall mission. So the key method for ensuring continued engagement going forward was through these feedback forms that we created in each pilot building. So a key group of building actors and target users that could give us honest and open feedback as to what would work for the building and also for the users of that building. So during our kind of what could be classed as the define stage, we held 2 different feedback forums with users, and this was mainly focused on helping us kind of identify what the users wanted from their ideal energy efficiency ICT tool, and what was of key importance to all the building users. So obviously our kind of feedback forms included those that might be in energy management roles within the building, but also those that could be classed as just kind of everyday users, or sometimes even kind of periodic users. So really we used a lot of kind of interactive activities to get the user to tell us what would work for them. And then our task was obviously to try and analyse a lot of those findings to find the similarities across all of the pilot buildings for where we could focus our tool that would work across all of these buildings. So during the develop kind of stage of the design process, it's expected that there's like initial development testing and refinement of potential solutions. And for eTEACHER, this meant using further feedback forums to get initial impressions of our first prototype of the tool, and taking those end users on kind of a user journey and understanding what worked, what didn't, what could be improved for the user experience to be something that actually they would enjoy and be keen to kind of continue engaging with in the future. It also acted as a means to keep the users engaged with the project during what could have been a long period with little interaction from projects. So often many research projects do a bit of initial kind of scoping, and then they go away and develop an intervention. And actually during that development stage, there's often little engagement with the building users. So you can then lose interest from those building users, but also they can kind of change for who might be in certain roles, and then they might not actually be aware of the project. So it was very important for us to kind of keep that engagement throughout this period. But this stage also utilised these kind of feedback forums as a way to cover another 2 steps of our enabling change framework, which were to frame a hopeful invitation and find the right inviter. So really understanding the building context again to find out kind of what methods and channels of communication would work best within each pilot building. And then the final design stage, which the eTEACHER methodology can be mapped against, was deliver. And that's where a final solution was selected, refined, and then launched. So aligning to the enabling change stages of kind of pre-test and learn. So during this period, the feedback forums were used as open dialogues with users over what was working, where things could be improved, what actually users thought of the tool overall. And a number of further engagement strategies were used during this phase to encourage increased engagement and interaction with our tool. So we used kind of email campaigns with weekly tips and hints, and we focused on introducing a particular feature of the tool each week in more detail. And then we held a webinar across a number of the pilot buildings for end users to see the progress of the project, but also how their input and feedback helped shape the final tool. So to come back to this presentation's title, User-Centered Design and an Energy-Saving App, Does It Work? Well, in the case of eTEACHER, I would like to say yes. During the project, we've collected valuable feedback from our target end users, and we've developed a relationship with those end users. And users have felt informed and valued with respect to how the project developed. Overall feedback from users has been positive, and even though there has been challenges along the way, we believe that the users have felt that we've listened to their feedback and tried to resolve matters as best we can. So user-centered approaches to energy efficiency behaviour change interventions can aid the design and development of effective tools which work for the user and take the user's needs, motivations and interests on board. So developing a tool with the user which works for the users. And it helps to provide a more holistic approach to encouraging behaviour change with end users. So one of the key findings I would say from our work has been that understanding the context behind any intervention is essential to its success, and ensuring that engagement with end users throughout is essential to build a strong foundation for pre-testing stages and learning what really works within a real world context. And I think we need to ensure that energy behaviour change interventions are fit for purpose and designed beyond the kind of low-hanging energy efficiency fruits. So thank you. I'm happy to take any questions within the Q&A session later, but also if you do want to reach out, then my email's on the slide as well. Okay, and I'll hand back.
Thank you, Ashley. It was a very nice presentation, and you did perfectly with the timing also. So please do not hesitate to include your question in the chat, and we will collect them all at the end of the session, and we can come back and discuss with Ashley about our behavioral change. Now we will go to the presentation of our ICT tool. So the next section is designing an energy saving app from scratch, the eTEACHER tools. And we will have 4 presentations from our 4 software developers. And so to start with, we can start with Nicolas Meyer from Ascora.
Hi.
Please, Nicolas. Okay.
So you should be able to see my presentation.
Yes, we can see it.
Okay. Yes, I will start with the eTEACHER tools, especially the advisor app, which is some part of the user engagement part where Noemi talked about. In general, we started from the idea and had some approaches, mocked it up, and later on we got feedback, which was collected through DMU, which were seen in the pilot sites and so on, and all that influenced later on the design of the app or the architecture of the app, and then we implemented it. And after we implemented it, we got feedback, which just flow back into the app to improve it further on. We had some problems at the beginning, just to find a way to actually engage all the users. Therefore, it was critical that we are on every device visible. That means since everyone uses smartphones these days, we tried to cover those and PCs and so on as well, so that everyone had the opportunity to actually use it. At the end, we used web technologies and created an Android iPhone app and a website for that. The final architecture is looking like that. We used new technologies to actually enforce that it is relevant still in some years, and even some stuff like PWA, which is at least from a technical point the most state-of-the-art to actually produce apps and websites at once. We also tried to have the opportunity to scale it up in a big way, so that we had a service-oriented architecture there, where we could develop and improve while doing it. So at the end, we needed like 5 minutes to actually publish some change we made, at least to the website, to the different Play stores and so on. It takes usually a little bit longer. When it was running, we had several statistics we monitored. We looked on when the people engaged with the app, when the people, what they used, and so on. If everything works out, we had several automatisms. If something didn't work out, that automatically the problem was tried to solve, so that we are actually can scale up without many problems. One minor problem there was to actually get the data when people engaged with the system and the features they used. We had the problem that the data anonymization was in the way. Since we had to make some kind of data anonymization, so we had to look on what kind of data we can get without breaking the data anonymization, which was even not that was not possible without major changes. And that's something we did. A lot of stuff for the identification is happening on the device at home, so to say, and our servers are not actually knowing who is exactly communicating or which apartment or whatever is belonging to that users, because that is majorly done on the application. With some information we got from the application, we could do that, but there we would have needed the help of the actual user to get that information. At the end, we have multiple statistics and tried to use that to improve the app as well. as well with feedback. And those are a few screens of the app where you can see how we managed different recommendations we've shown, where we will hear more about later on. How we tried to engage with the user, how people could actually share their content on social media and connect through social media their accounts for the gamification part. A big problem here was as well that we had to find a way to actually have the own language of each pilot in there, which is, at least for us, was quite unusual for a research project to have it in that amount. So we needed a way to actually do that and have an easy way that people can actually help us with the translation. Further, we had several, we had to find a solution to actually integrate our solutions with the others we will hear about later on. And quite a few calls actually finding a solution for that. The gamification part is quite interesting as well, since not everyone is actually the same. People have different motivations, and we tried to cover some of them to see what is working the best for everyone, and for special groups so that we can focus on different parts. We had tasks in general, which were recommendations, which were auto-generated, which you could follow, where you got points, which were, the amount of points you got were associated to actually the energy you saved or the CO2 you saved. We had missions as well, which were reoccurring tasks, where you just got the task to actually reduce your consumption for a week, for example, and at the end of the week you got just your summary, how well it worked out and how much you saved. We had informal presentations where we just showed how the energy distribution is, so that you actually know, okay, when my heating is the biggest contributor to the energy waste so far, then you know, okay, perhaps I should reduce the heating. We had a competitive part as well, where it was a ranking, where the anonymization part was a problem as well. But we solved it, and you could compare to the next one where you actually didn't know who it is, the average guy and the best one in your cluster, so to say. And you could also link with friends, and then you could see each other on the ranking and see on which place you are, and interact with each other. You also had possibilities to see the impact on a personal level, which was behavioral based. So it wasn't associated with the tasks we had there. It was just showing the energy consumption in general for a certain time span of different devices like cooling, heating, appliances, and so on. And further, you had the opportunity to see how your energy consumption was in this week compared to the last week, or the same for a month. So you could see if your behavior actually changed anything. And the only thing you needed to contribute is the energy used on that we have a sensor which measured the energy use. We had another point, which was the general impact, which just calculated the energy saved on your apartment and calculated how many trees were saved actually with your CO2 reduction. So you could actually see how much influence it had that you try to reduce the energy. So yeah, that was the part of the advisor app. If you have questions, you can.
Thank you, Nicolas. I think that the question should be asked at the end of the session. Okay, thank you very much. So now we will have a presentation from Hervé Prouvost from Fraunhofer, who will be explaining about the what-if analysis.
All right. Hi, good morning, everyone. Do you see my screen?
Yes, we can see it.
I mean the presentation screen.
Okay. Now we are watching the two slides. So
Okay,
I think we need to the other thing.
Yeah, just switch the screen. Yeah. So that will be right now.
Yeah, that's perfect now.
Okay.
Okay.
Well, I'm Hervé Prouvost. I work at Fraunhofer, and so we focused on the what-if analysis of the eTEACHER toolbox. So the what-if analysis is this component in the green circle. This is one of the box add-ons that Noemi mentioned, and so it's analysis service. It's an analysis service which is in between the universal data communication interface. So it uses building data, and then on the right side, it provides outputs to the end user level, to the app front ends that Nicolas showed. And for doing this this tool, so the main goal of the tool is to analyze building data in order to automatically identify suitable energy conservation measures and translate them into advices, so recommendations that can be provided to the end user through the advisor app Nicolas showed, for then engaging their actions toward more energy efficiency. And this energy conservation measures that are meant then to be applied by users in a similar way as by control systems, but the difference is that it is not a control system. It is a recommendation system which to recommend control actions to end users. That's why the term indirect control. And we had several constraints along the project. The first one and a common one in the field of data analytics is the availability of building data and their quality. Also, the tool is to be applied in real time during building operations, and it must be always available. Also, the computational time, because it's a real-time tool, so computation have to be limited. And also, one major aspect is the flexibility to be applied on several buildings, because eTEACHER the project with many demonstrators with the various type and usage, and this is also one of the major aspect is to be able to apply it on many buildings, and also the runtime environment where to run it or to use resources, computer resource for that, and now I will dig a bit more into this aspect. First, so we had to in the project to define the energy conservation measures. So this was made by the means of surveys and common works between different partners, and we split it so energy saving strategies in four main categories according to energy types: cooling energy, heating energy, energy used for lighting, and electrical energy for appliances. And we then define different strategies how in these categories people can save energy, and by means of which actions. So roughly, the main action can consist of optimizing solar gain, acting on blinds or windows, also avoiding overcooling, overheating and undercooling by adapting thermostats or set points or radiator valve positions, also avoiding wasting energy when the facility is not occupied or appliances are not used, and avoiding also HVAC operating errors. So, and then for the what if analysis, so we summarize all these strategies and potential actions into a knowledge base, and then we implemented it in a computer readable form, and then developed such architecture, this architecture accordingly. In fact, the what if analysis, it's developed as an expert system, which contain three main components. So fact base, in which data, so real data from the buildings, is imported, the knowledge base, which then summarized in computer readable language all the energy conservation measures, potential recommendation strategies for energy saving, and the algorithmic part of the tool and reference module that can compute on the basis of the fact-based and knowledge base. So real-time recommendations and advices, assigning them then to specific building elements, building spaces or zones in the building. And the tool we have deployed it then as a service. So this runs as a cloud service remotely at front of our premises, and communicate with the input layer, which consists of the universal BACS communication interface, respectively to the building monitoring system of the project, which is presented in the next presentation by my colleague Brian. And for this monitoring system, so we defined an architecture and a database schema using metadata about the building, its topology, as well as including the measurements. And for that, and for communicating remotely over the web with these components, so we implemented an OPC UA interface, which means Open Platform Communication Unified Architecture, which is in fact a standard, so communication standards from the automation field. And then the what if analysis gather this data constantly, continuously over time, and analyzes it, and then perform its inferences, and then send the results also over the web using a REST API to the eTEACHER app server. Here's an extract of the front end application of the advisor Nicolas mentioned. So this feature, so the what if analysis, you can when using the app, you can find it in the recommendation view, in the recommendation menu of the app, and this gives over the app continuously over time different recommendation based on the data which is analyzed. Then providing users with potential actions they can do to save energy, and also estimation about how the saving potentials of each recommendation. As a conclusion, the what if analysis is in fact a recommendation system that rely on building data as well as metadata. It provides the end user with energy conservation measures in real time, compared to former or comparable system, which are rather based on general advices and offline, so non-database system. Also, it is model-based, that bring much flexibility, model-based, because it relies on metadata about the building. So the tool is designed and developed to reuse and to interpret the building topology and the sensor installed this information is gained by the monitoring system. And then this allows us to have a tool which can be nearly easily applied to other buildings without having to reprogram everything, because each building has different spaces or different sensors or different usages. It runs as a cloud service using web compliant protocols, and it allows us to have a tool which is easily installable and replicable in other buildings worldwide. And as I mentioned, so it acts similarly as so it is a kind of control system, but it's instead of managing actuators or a control system in the building, so it sends a recommendation to end users, who then can perform control actions and become part or real actors in the energy efficiency of the buildings. And we have also identified so many further applications and extension possibilities of the tool. The one is to extend it with building information modeling and digital twins. So as I said, it relies on the tools use metadata about the building, and BIM and digital models of buildings are a source of a lot of metadata, which can also extend the use case possibility. Also, the knowledge base can be extended. So this is something we can let grow over time, find new use case, for example, for fault detection and diagnosis. And also, that would be good also that we couple also this recommendation system with other kind of analysis, like simulation at energy system level, integrating also the control system and maybe also the user actions, and also coupling it with AI-based energy system control, like, for example, using reinforcement learning for generating optimized set point schedules, or even switching time of multivalent system, multivalent in terms of different energy production systems, like heat pumps or boilers, if a building had different production system. And yeah, that's all for my part. Here's my contact. If you want more information, do not hesitate. Then
we cannot hear you, Noemi.
Yeah, sorry, I was thanking Nicolas and Hervé for keeping the time and for their interesting presentation. So now we can go to the presentation for Alina from Granlund. So maybe Alina, you can turn your camera on if possible. Thank you.
Yes.
And also share your screen.
Yes. You can see it now, I assume.
Yes, we can. Yeah.
Okay, perfect. So hello everyone. I'm going to present now the comfort conditions tools, which are part of the end user feedback section in the big diagram of eTEACHER tools. And the main goal we had was to improve the indoor air quality conditions without compromising energy efficiency. And we did this by implementing 3 different tools. The first one is the comfort opinion, which is targeting the building end users and allows them to give feedback about the indoor air quality conditions in the building. This application can be found in eTEACHER app on your comfort opinion, and it allows the user to say if they are satisfied or unsatisfied with the indoor conditions, and also give a more detailed message to why. Then the user is redirected to another page where they can see a history of all the comments from other people. And it's a very user-friendly and easy to use because it works in a similar way to social media, where users can react to other people's comments and also give replies. The users also can filter the information either by a different time frame or based on the response, or they can also sort the replies based on different categories. The second tool is the virtual building, or the digital twin as it's known in the industry. And this one is also directed for the building end user, but compared to the comfort opinion, it offers different types of visualizations of the indoor air quality conditions. And it can also be found under virtual building in the eTEACHER app, and it shows the 3D model of the actual building and builds the visualizations on top of it, so it's easier to understand which corresponds to which. Like, for instance, here we can see the occupancy of these rooms and see which ones are free and which one is occupied, and this is the latest data coming from like 5-10 minutes ago. Sorry. Also, we can easily check different types of indoor conditions like temperature, CO2, or humidity. And by selecting one room on the model, we can also get a detailed list of the current indoor conditions in that room. And by selecting history, we can see a chart with all the indoor conditions available and see how they relate with each other. And we can also change the different time frame to see data, earlier data or later data. And another type of visualization is the report of the CO2 levels, which can be calculated either at room level or at floor level by calculating the average of the CO2 levels. And this was created with having in mind the idea of observing potential patterns in the data and seeing how it can correlate with other indoor condition information. And this also like shows us the busiest times in the office of this building. The third tool is the comfort conditions tools, which compared to the first two tools, which were directed to the end users, this one is directed for facility managers, which who are more interested in in-depth analysis of the indoor air quality conditions. And we have two tools for this, Metrics and Pulse, which can both be found under comfort condition details in eTEACHER. And Metrics shows the performance score, which is calculated based on the CO2 levels, the temperature, and all the other air quality information. And if we click on conditions, we can get more detailed information for each space in the building. And for example, if we select temperature and one of the spaces, we get a detailed chart of how the temperature has varied during the month of May and how it compares to the upper limit represented by the red line and the lower limit represented by the green line. And also what is very important is that we see how this temperature has varied compared to those two ranges, which is given by the temperature persistence, which is like the beige colored line. And this persistence is actually the value that goes into calculating the metrics score. Now, Pulse also gives us a score, but this score is an overall one, which is calculated based on the metrics score, which is given from the building automation system, and also the score from the comfort opinion end users feedback. And we can see here that we also see the trend of this score over the past 30 days. And we can also check the Pulse report, which gives more detailed information about what this score means and whether it's good or bad. And this report is generated monthly. So throughout the project, we faced several challenges. One of the biggest one was to find a way to visualize big amounts of data in a clear way for the user to understand. So we solve this by trying different types of visualizations and collecting user feedback on them, and figuring out which ones work best for the user to understand, and which are the best types. Also, we had a lot of data coming in from multiple sources in our system. So we decided to standardize it using an internal API. But one drawback was that it added a bit of an overhead in loading the virtual building. We also noticed that the feedback was not localized well enough, meaning that it was quite difficult at sometimes to realize whether the user was giving feedback for a room or for the building. So in the latest version of the virtual building, which is available for the eTEACHER demo building, we added this feedback feature in the virtual building application. So all in all, we implemented 3 tools to improve the indoor air quality conditions without compromising energy efficiency. That was my presentation. Thank you.
Thank you, Alina. It was very clear and very focused. Thank you. So now we will give the floor to Florian Frank from IFM.
Okay, you should see me and you should see the presentation right now. Perfect. Yeah. Hello everybody, I'm Florian Frank. I'm from IFM Software GmbH, and within the project our task was the Universal Building Communication Interface. Within the scope of the project, the UBCI is located at the start of the chain of all the software tools that were just presented. This means we have to pick up the necessary data right from the building automation and control system, make it available for all the following software components. The UBCI container itself consists of several software tools, the main one being the Common SQL database, which is available to third parties, third-party software such as BACS, for direct logging using standard SQL connectors, so they can read and write the data directly to the database. The second tool is our API, and together with the API we developed the synchronization tool, which allows it to connect to other MySQL databases, query them, and store the data into the common database via our API. Finally, we have the eTEACHER OPC UI interface, which we developed with our partner Fraunhofer. And the OPC UI acts as a software server, so it's kind of complementary to the API. First step of developing the SQL database was creating the entity relationship model. So with the entity relationship model, or with the development, we relied on our experience, also followed some other standardizations such as the Zaref ontology. And the entity relationship model basically describes how the database is set up. It lists all the tables, for example, a table that lists all the floors of all the pilot buildings, and it also lists the relation to these tables from one to another, so you know in which pilot building a certain floor is. Obviously, we also store all the data of the meters, such as, for example, what kind of measurement the meter measures, be it humidity or temperature, the unit, and the like, and obviously the measurements themselves. After we developed the entity relationship model, we had to decide which database management software we wanted to use. From our side, we wanted to use the Microsoft SQL Server because that's the one we were most familiar with. However, due to some of the sensors we used actually being able to log directly to MySQL databases, and due to already some MySQL databases used in the national databases for the national pilot buildings, we agreed on using MySQL, open source database management software, which is backed by the Oracle Foundation. That also allowed us to use the PHP MyAdmin software, which is also open source and allows to administrate the database over a web browser, which really helps when you can't access the server physically. All these tools are run in the virtualization software Docker, which I guess I skip due to time. Yeah, next up is the eTEACHER API. The API is the second main result. It follows largely the structure of our common database, which means you can query all the tables, include the filters. We also created some sort of wildcard endpoint, which means we can call a procedure that is already predefined in the database. And we done this so if the requirements from our partners changed and you needed a certain set of data, we could simply create a query on a database level instead of having to develop a new endpoint for the API and then having a new API release. Together with the API comes the sync tool. So the problem is the database is, well, not a problem. The database is hosted with our partner Ascora in the cloud. Now, if the database was available just right through the internet, this would pose a big security issue. So we had to find a way to securely access the database. Hence, we created the API so we can control what queries can be done and who and where you can access the database. And together with that, we developed the synchronization tool, which allows us to connect to the MySQL databases in Spain and the UK for the pilot information there. And the synchronization tool basically queries the measurements there, stores them, and then uses our API to move them into the common database. Last but not least, there's the OPC UI. For this one, we work closely together with Fraunhofer because in the end, they had to approve the structure of the server on how the data is provided. So as said, it's a server. It provides a tree-like overview of the project sensors and where they are located within the pilot buildings. In order to provide data, we have an implementation that queries the SQL database every few seconds in order to be able to provide live data, live in quotation marks, because we have a several second delay depending on how often we query. Now, finally, I would like to say something about challenges that we faced during the course of the development of the project. One of the biggest challenges we had was the decentralized structure. So we had 3 national databases for each country where pilot buildings were located in. And we had to find a way to feed into a common one to have a common database for all the other software tools. So one solution, as mentioned earlier, was the synchronization tool. However, it also involved a lot of manual labor, such as manual exports and imports of the meter data, because if you do not have a meter set up in the common database, you cannot synchronize measurement data for that meter. So it was a whole staggering of the pilot managers having to introduce the sensors into the building and then into their national database and then finally into the common database. A second issue was the sensor reliability. Some of the sensors would run on batteries and then fail because the battery life was at an end, or there were transmission errors which resulted in incorrect measurements. And the main problem was that we did not store all the available metadata for the meters because those were in the national databases and we wanted to focus on the main and important data. So at the end, we had to result on plausibility checks. So for example, we run a procedure every night to check which sensor did not provide measurements within the last 24 hours and provide the results as a few Third and final example of challenges would be the incorrect resolution of sensor measurements. This is mostly in the electricity meters, and that is because each time they send a measurement, they send the summed up consumption from start of measurement up until this point of time for the measurement. So in order to get the consumption for a different for a certain day, we had to actually take the measurement of the beginning at the day and the end of the day and subtract one from the other, which sounds like an easy task, but in the very end you have to do a lot of cross checking to find the two most or the two correct data sets. But we overcame this and have a trigger running on the database, so as soon as there's a new measurement, the subtraction will take place. Okay, thank you very much for your attention, and that is me ending.
Thank you, Florian. Very interesting. So I think we can have a small break of 5 minutes just to stretch our legs or maybe go to the toilet. So it is maybe we can meet again at 5 to 12. Is that okay for everyone? So maybe we can write in the chat. Maybe.
Yes, okay, Noemi, I will write it in the chat.
Okay. Okay. So see you in 5 minutes. Only 5 minutes, please. It is 10 to. So thank you. So now we can start the second part of our conference, and so we will start with the methodology for a successful integration of the eTEACHER monitoring system and solution into the different type of buildings. And so we will have a presentation conducted by Jacobo Peralta from CEMOSA. The floor is you, Jacobo.
Okay, Naomi, thank you very much. I guess that you can see my screen.
Yes.
Okay, thank you. Okay, this presentation is about the methodology that we have designed and used during the eTEACHER project to integrate the different solutions that you have shown during this morning with our partners presentation. Okay, the goal of this methodology is to integrate these solutions, these ICT solutions, addressing especially the behavior change. So the challenge that we have addressed during the project has been the following ones. The first one has been that, of course, every building is different, so we have to address different facilities, the type of the building used, the buildings are existing building and not new buildings, so this is more difficult because we have to deal with different facilities and previous designs of different monitoring system or control systems that are existing in the buildings. The second one is as this methodology, the aim is to identify the behavior change during the project and quantify how this behavior change influence in the energy consumption. The definition of a consistent baseline is paramount in this aspect, but the problem is that most of the existing methodologies to evaluate the energy consumption change when we apply different interventions has considered the behavior of the people as an uncertainty, but in this case it's something that is on the focus of the project, so it's difficult to define a consistent baseline. The third one is the monitoring system and installation, because this kind of project needs many sensors to quantify how the people is, the behavior of the people, and how the people is working or living in the different buildings. So this request a lot of sensors to monitor these kind of issues. And the last one is the certification schemes that in general, when we get this kind of certificates from the different buildings, the use of the building and the user behavior in general is not considered and not quantified. So these are the four main challenges. For the first one, using our previous experience in energy audits and evaluation of the energy efficiency in different buildings, we adapt existing standard templates to include the interaction of the user and how the users use the building. So we prepare this template, which can be found in the deliverable that is public 4.1, and this can be used by anyone to prepare the visit in order to address and to identify the points in which you have to pay attention to describe how the users building users use the building, and which kind of potential target behaviors can be identified and quantified during the evaluation. For the challenge number 2 is the issue with the baseline. Usually in research projects of energy efficiency is using a baseline that is based on regression mathematical models. For example, we can find alternatives like degree days in order to compare before and after intervention of the different projects. However, this is not totally fine in our approach because we are addressing behavior change. And for this reason, we base our methodology in the eMeasure methodology that establishes 3 main points to create a consistent baseline. The first one is that experiments should be replicated. So the first one is we need to keep similar conditions before and after. The experiment period should be long enough. This is important to keep the condition in similar ways. And the third one has the different versions, but selecting in this project was to create a control group in our target buildings. With this control group, this is the main point of our methodology because we select a specific room, non area in the building, in which can be similar to other parts of the buildings. And the good point is that we select in this way we select properly this room, and the behavior of with similar rooms, the people behavior is similar. Even the orientation, the use of the facility, appliance, and so on, we can compare before and after with in similar conditions. So the advantages of use a control group, as we have done in this project, is that we can go ahead to performance guarantee because this provides more credibility in our proposals. We increase the robustness against external conditions because we are using uncontrolled and study room. So the external conditions affect similarly to both rooms. It's easy to identify outliers or generate alerts in the case that the control and the study rooms differs in some values. And of course, the comparison, as you can see here, is enriched because in a classical approach on the left, you can see that only we have 2 points before and after. So the comparison is very simple, and it's very difficult to explain and describe the problems that happens usually in this kind of project. But if we have used 2 different rooms, one monitored and other one in which we apply the interventions, we have more points to make analysis and to explain what is happening and to provide more probably scenarios that this is happening. However, it's very important, I would like to highlight that these similarities that try to be addressed with the control group shouldn't be changed during the experiment. And this is the example that what happened with the COVID-19, in which this changed everything, even the use of the building, even the use of the rooms, the occupancy of the room. So this is something that we have addressed during the project that has been very difficult. And this is something to be considered. It's a robust approach, but not against pandemics issues. The challenge number 3 is regarding monitoring system, as most of the present project here has keeping in mind. The issue here is that the behavioral change estimation to save energy is about 6–10%. However, the cost of sensors, even some projects presenting this morning like feedback, has to be deployed their own sensors, is because sensors are expensive, and to identify and to quantify the behavioral change, it's important to monitor a lot of information, a lot of data. So it's not justified in all the cases the payback time of all the solutions. So in eTEACHER, one of the challenge has been to play with this limitation in the budget. And one of the conclusions that we can highlight in this point is try to avoid battery operated devices unless it's necessary, for example, for doors and windows. Address electric panel boards, because there are commercial solutions now that allow us to monitor directly most of the energy consumptions in the building, even to monitor different data points, and address the smart meters if it's possible with an utility company that can access directly to the information, even can apply new innovative disaggregated methodology to identify different type of energy consumptions. And here you can see our whole picture of the integration methodology with different steps using the building modeling notations. This is very familiar for most of you. This is our integration methodology, in which we have identified the energy auditor. This is mainly the engineers, the architecture, the people that trying to design the energy efficient solution or the interventions to change the behavior of the building. We have the building owner, that can be the building owner, building facility manager, and so on. And the ICT provider, these are the company responsible to provide the ICT solutions, sensors, mobile apps, etc. So we have divided the methodology in 4 main steps or milestones. The first one is preparing the visit, in which you can use the template provided in the deliverable 4.1. You can check online this deliverable. So you can use this template to contact firstly to the building owner or the facility manager in order to take all the main information and prepare the visit more efficiently. The second one is the technical visit, in which we are going to interview the facility manager and all the relevant staff that are involved in the main potential target behavior that can improve the energy consumptions. And then with the technical visit, the idea is to identify which rooms can be controlled and which room can be studied, in which with the idea of define the baseline of the building in order to guarantee the improvement of the energy efficiency of the building. The third step is to define the data point. This is an iterative process with our client in this case, and with the ICT provider. In the moment we receive the validation of our client, we can send the specification to our ICT provider in order to deploy the corresponding sensors to get to gather all the information that we need to evaluate the behavior change. And finally, the designs of the monitoring system that is mainly addressed by the engineers and by the ICT provider in order to monitoring costs with the maximum reliability. That's all from my side. So thank you very much.
Thank you very much, Jacobo. Very interesting. So again, I would like to remind you that you can ask your question in the chat, and then we will go through them at the very end of the conference in the question and answer session. Please do not hesitate to ask the questions. So now we will go to see how we have implemented the eTEACHER solution in our pilots in Spain and in Romania. So we will start, the session is how is it going? Practical example from our case studies. And we will start with our colleague Francisco Marquez from Agenex. So hello, Francisco, the floor is yours. Maybe, yeah, you can turn your camera.
Yeah, thank you. Thank you, Noemi. Hello to everyone, and thank you for the opportunity to show how we are doing, we are implementing this project here in Extremadura, in Spain. Are you seeing my screen, right?
Yes.
Yes, okay. So we have in the region the most of the building typology of the project. We have healthcare center, office buildings, schools, residential building, and we have made a great effort in installing the sensor. We have installed more than 200 sensors, in fact 225 sensors, with more than 300 measure, okay, because some sensors can measure different measure, okay. These are the buildings. All the Spanish buildings in the eTEACHER project are located in the region of Extremadura. This is the 50% of the pilot buildings. How to engage all these different buildings? Well, the easy answer to this question is by collaborating with local or regional partner in this case, such as energy agencies, because we can address all these kind of buildings, okay? Other issue that we have found in the eTEACHER project that we happy solve it is the interoperative communication, okay? We have wire and wireless communication depending on the sensor, and we have big buildings. That means that the distance was a barrier, okay? The solution was a mixed approach. On the one hand, we take the seat wave connection, that was a radio connection. It means the wireless communication, okay? And on the other hand, we have several sensors that are mainly located in the switchboard panels that need to be connected by wire, sorry. And in this case, we made a handmade gateway based on Raspberry. Okay, another sensor that also was handmade, like the weather station located in the buildings, with aim to fulfill all the requirements from the project. This is an example about where the sensors were located. This is one of the buildings, the healthcare center of the Guarenya city. And if you see the map, the sensors are divided at room level and at building level. All the sensor, or the most of the sensor located at building level, it means that they take data from the whole building, are located in the room for the switchboard panels and the facility room or something similar. These are all of here. And the sensor at room level, Jacobo has explained how this we have a room, a control room and a study room, okay? In this case, the study room was this part of here, and the control room, this other part of the building, okay? This is just an example. This is how the sensor looked like. Some sensor was hidden in box in other places, but other ones was in the windows, in the door, in order to check if these windows and doors are open or not. Okay. Even others show information directly to the user. Okay. Other question that we made when we are designing the teacher application was how to store the data. Okay, because it was very important, the quality data, and ensure the good quality of this data. Okay, so we take a mixed approach again, and we selected a local database that was placed in our region. And this data structure, at the beginning we have buildings, sensor, measure, and finally the data. Okay. The last question was how to engage people. My colleague Ashley has explained very well how to do that. But one of the success from the eTEACHER project was to use the user feedback for designing the tool. The eTEACHER tool was something that the user want to have it. Okay. How to do that? It's about with a continuous communication with the building staff. From here, from INS, from the Extremadura Energy Agency, we are in continuous contact with the building staff, mainly the building manager or facility manager of the buildings. That's all from my side. Thank you for your attention. And any question can be put it in the chat box. Thank you.
Thank you, Francisco, and thank you for taking the time, and it was very interesting. So now we will see about the development in Romania. So our colleague Paula Angelita will present the developments in Romania. So maybe Paula, if you can also turn your camera on. We can see the screen now.
Yes, can you see me? Can you see my screen?
We can see the screen, but we cannot see you. I think your camera must be off.
Yes.
Now
Yes.
we can see you.
Okay. Hello, I am Paula Angelita. I am from ICFE, Romania, and I will present some aspects about Romanian demo site within the eTEACHER project. You can see my screen?
Yes.
Okay. Our demo site is situated in Bucharest, that is the capital of Romania, close to the city center, and is composed on 4 new and modern apartment blocks, each with 30 types of apartments distributed on 17 floors. The apartments in residential complex combine general spaces and decoration features with a complete finishing solution, all in a modern and minimalist decor. The residents have a lot of space or green spaces, security, underground parking, fitness center, playground for children, and the beauty salon. It's a new and modern space used for our project. A few words about our demo selection. 4 apartments were chosen as study zones and another for control zones. We keep into account the idea to have similar space to be monitored, because it's important to compare similar conditions. 3 rooms apartments were selected. The sensors were placed in the central area in the living room. A few words about the challenges addressed in our case was about sensor selection, about relevant parameter to be monitored, integration of the existing data from the in-city building BMS was another issue because the building have automation already installed, and we have to capture the data from this. Was an IT intense effort. About data collection, transmission and storage. And also we consider that another challenge we addressed was about stakeholders and people involvement. About a few words about the monitoring system developed in Romania. We follow the way in searching, in finding sensor already commercially available that are suitable, were suitable for our application. So we used NetAtmos sensor to monitor temperature, relative humidity, and CO2 level in apartments. For solar radiation, we used the pyranometer Kippenzonen model. For apartment level monitoring of the energy parameter, presence, occupancy, light intensity, we used the Homatic solution initially in this structure, and then we developed another solution. For monitoring the energy parameter at the building level, we used Lumel solution that added supplementary measurements for energy monitoring for different branches necessary to assess different energy consumptions. And here is an image of the building management system already implemented in the in-city residential buildings. Here is just an image about the energy monitoring system we implemented based on Lumel sensors. There was a lot of parametry interested very interesting about consumptions on different branches, such as elevators with lighting and a lot of aspects related to facilities already in work in the in-city residential. At apartment level, this is the situation about the parameter we monitored, and also the apartment positioning within the 4 building we choose for as demo sites, demo apartments. A few images about installation work. Was an effort from our team with the help of facility managers, of the staff in city buildings. We succeeded to install many sensors, meters. Here are current transformers. We used the Lumel current transformers. At apartment level, here there are few images from an apartment. The owner agreed to take some photos, highlighting the situation in the electrical panel. We wanted to use the flash mount solution, but in few cases was not possible to install because of the lack of the spaces. But we found alternative solution to see the energy consumption. at apartment level. Yes, and another issue addressed, another challenge was about the data collection, transmission, and storage. And here are some is highlighted the flow of the data. So for these equipments, the parameters, the data are stored and in the local database and then transmitted to eTEACHER database. But in the case of a Homatic solution and the later solution we found, the data are transmitted directly to the eTEACHER database. With the limitations we found later, but it is a space to improve and to develop better solution in the future. And in the case new projects, why not? About challenge about stakeholders and people involvement, I want to highlight that was very useful, helpful, the feedback forums we organized during the project. The people interacted, socialization was a very, very good background to achieve the wanted results. Unfortunately, the pandemic COVID was not good in this aspect. We communicated mainly online. And this was my presentation.
Thank you, Paula. So after the presentation of the two pilots, the demonstration in two of our countries, we will go to the section on the suggestion for policymakers, so that the policymakers can incentivize behavioral change. For this section, we will count on Francisco from Agenex and Andy from Nottingham City Council. So I think we can start with Francisco. So the floor is yours, Francisco.
Thank you again. Hello to everybody again. And I think you are seeing my screen now. Okay, yes. Now we are speaking about suggesting for policymakers to incentivize the behavioral change. Okay. Okay. Let's see. Well, the Spanish, Spain. In this speech, I will speak only from Spain, because my colleague Andrew will do from the UK perspective. Okay, Spain is in the European renovation wave. This means that the focus is on the technology, on the energy efficient tools. This becomes that the building energy rehabilitation is a priority, not only at European level, but also at national, Spanish in this case, regional level. Okay, and here in Spain we have the national and regional plan for the energy and climate. This means there are two plans, one at national level and other one at regional level here in Extremadura. This means that some regulation mention the energy monitoring system, okay? But to be honest, there are a few on this section, and grants for include this kind of monitoring system in the buildings have been also offered to the citizen, to the user, and even for building manager, because it's not only for residential building but also for non-residential building, okay, like office, healthcare center, whatever. And this is how is working now, but we think that currently the new policies that become in the news the incoming years should improve this situation. For example, we have the ERESE. ERESE is a long-term plan for building rehabilitation, and we are applying to the people who were in this plan in order to include the monitoring system as a way to reduce the energy consumption in the buildings. Okay. We are doing at national level in this plan, but also at regional level in the strategy for energy efficiency in building, named E4PAREX, an acronym. Okay. In fact, the regional government has been interested in the eTEACHER perspective because eTEACHER put the people in the focus. I mean, not only the building, but also the people. And we think that is other success from the project. Before eTEACHER, in our experience, our target user was the building and facility manager. But after the eTEACHER has put the whole building staff in the spot, and we think that is a better approach. So we have learned a lot about in this project, okay? And we think that emphasize the human behavior component is one of the best recommendation. My colleague Andrew speak better than me about the behavior change because he have found other issue and other solution. Okay, so again, this is all from my side. You have the chat box in order to make question or whatever. I am happy to answer all your doubts. Okay, so thank you again.
Thank you, Francisco, for sharing us the point of view of the Extremadura Energy Agency in Spain. So now we give the floor to Andrew Whitley from Nottingham City Council, and he will share with us the point of view from the UK and from his area. So Andrew, the floor is yours. So we can see you now, but we cannot see your screen.
Presentation. Yeah, thank you. Can everyone see the presentation okay?
Yes, I think you need, okay, that one, the first. Yeah, you need to go to.
Okay.
Okay, that's fine.
Is it okay now?
Yeah, yes, we can see just the
okay,
slide.
Thank you.
Yeah,
I'm just going to. Sorry, you can just see the slide. Or the notes.
No. We just see the slide, so that's perfect. That's the way.
Okay, sorry, Naomi. Okay, yeah, thank you. I'll start. So my name's Andy Whitley. I work for the council, one of the partners in the eTEACHER project, and I'm just going to talk briefly about incentivising behavioural change from a UK perspective. So we'll just currently go through the current UK policy, which is around. So the Energy Act in 2011 brought in minimum standards for domestic and commercial buildings sold or let from April last year, with the emphasis to improve the energy rating of this building. This encourages owners to improve efficiency by investing in energy efficient installations, but does not recommend behavioural change to reduce energy. The UK is also committed to a programme of replacement of all electricity meters to smart meters. Smart metering can assist building occupiers to see in real time their energy use, and it could be the catalyst to make changes in the way that they use their energy, particularly if the advent of smart metering brings in flexible charging and remove the traditional UK method of evening and day rates. This could incentivise bill payers to use energy more efficiently, but whilst it could be considered behavioural change, it's effectively a punishment method rather than a reward method. There are some other schemes as well. So there are tax schemes within the UK, and in electricity supply, there are many taxes imposed by the UK government to fund energy infrastructure. For example, the renewables obligation, which was expected to be an incentive to energy suppliers to find renewable sources of energy, is now passed on to the final end user. The feed-in tariff scheme, all electricity suppliers are required to make payments based on their market share. And this fund is used to make payments to the end users of self-generation from solar panels. However, as it's paid to the end users, it's effectively the consumer paying itself for self-generation. Consumers also pay for electricity transmission and distribution network, and for business users, a further tax is imposed on by the climate change levy, which is based on consumption. There are also other schemes in the UK to help plug fuel poverty, such as home discount, cold weather payment, and winter fuel payments. But do we really understand behavioural change? One size cannot fit all. Non-domestic buildings can be difficult sometimes to motivate behaviour change, as is often a misunderstanding of where responsibility of energy management lies, as employees aren't affected by energy costs, and barriers can exist where company priorities can often be in conflict with energy reduction. In domestic settings, whilst householders have control over energy use, barriers can still exist, social and financial, and this can prevent some households from carrying out certain actions. So we need to look at creating habits, and focus needs to be given on converting habits. Too often, behavioural change can backfire, as when the programmes only attract people who already engage in that activity. The key is to focus on the unengaged and why they undertake this behaviour, what needs to happen to change that behaviour, and how can they be motivated to change. This is what's different about eTEACHER. The social sciences has helped us understand the motivations, and the app has helped us in educating people in changing that behaviour on a daily basis. We also need to look at providing upfront incentives, and these do not have to be financial. And again, for behaviour change, you need to understand the motivation to break the habit and what the incentive could be. For example, in the workplace, an incentive for a member of staff will not be financial. A successful programme of energy reduction was completed in Nottingham across our leisure centres by tapping into the competitive nature of sports coaches and staff, and having a simple weekly league table. This motivated the staff to get at the top of the league. For domestic users, traditionally incentives have been financial incentives to kickstart a new market. For example, the feed-in tariff scheme and the renewable heat incentive pays owners of renewable energy installations for every kilowatt hour of energy they generated. However, many households could not afford the capital investment to store these, and the scheme changed, whereby companies paid the capital costs and charged the householders a lower rate for energy use for that installation. However, we should look beyond financial incentives, as they are often cost prohibitive in reducing energy use, and again, looking to the householder's motivation not to reduce energy and focus on cost-free ways of incentivising homeowners. Investments in low carbon or free energy can actually have a negative effect in people's behaviours as they become more wasteful in energy use, as they no longer have to think about the cost implications. It's therefore essential that any new renewable energy installations are backed up by behavioural change as well. So just in summary, a common theme for shifting behaviours is the emergent importance of data and ICT as an important asset for enabling consumers to make an informed decision about changing their behaviour. This is where the eTEACHER app comes in, with its ability to take in a wide range of data from building sensors, energy and weather data. It is able to present tailored suggestions to building users in real time to help them change their behaviour on a daily basis. Too many behavioural change strategies are too short-term focused to change people's behaviours to the norm. You only get short-term bounce before behaviours revert back to usual. The advantage of using data on a daily basis is that education becomes a daily habit, especially when the apps make suggestions and recommendations on adjusting your energy behaviour to be able to use the absolute minimum amount of energy. And thank you all for listening. Thank you.
Thank you, Andy. It was very interesting. So now, after the point of view of the policymaker, we have the last presentation from the eTEACHER project, and it will be carried out by María del Carmen Bocanegra from CEMOSA, and she will focus on the lesson learned and the final results of the eTEACHER project. So you can go ahead, Carmina.
Thank you, Noemi. Can you see my screen okay?
Yes, we can see it.
Okay, great. Okay, good afternoon, everyone. My name is Carmina, and I work from CEMOSA, who is coordinating eTEACHER project. And my presentation will be on the lesson learned from the project. So this is, as Noemi said, the last presentation before the roundtable and the Q&A section. So I divided the lessons learned throughout the project into 3 groups. First, the lesson learned from eTEACHER pilots. Second, the lesson learned from eTEACHER tool. And third, the global lesson learned from eTEACHER results. So from the eTEACHER pilots, we understood that monitoring maintenance is critical, and sensors battery is an important problem. And it was a common issue from all the different pilots in the different countries. So often checks are needed, and also in the future we can consider wired sensors to avoid the battery issues. For building dimensions, we learned that S-wave systems are good for small buildings, but for big buildings with a big number of sensors and also large distances, we need a Wi-Fi system better. Also, the reliability of the sensors and the data quality is an issue that needs to be considered and addressed from the very beginning of the project. So we need to think about data cleansing and try to implement algorithms to the reliability of the data from the very beginning. On the user side, user engagement is critical and is key for the project success, as we've been saying in the different presentations. So we need to inform the users. They need to understand what the sensors are for in order not to move them to another location or to damage them. And also privacy is an issue, especially in residential buildings. So again, people need to know what the sensors are for, what the project is about in order to engage with it and accept it in their lives. Also, we need to keep things simple and we need to measure only the critical parameters we need in order not to add complexity to the monitoring system and avoid problems. Again, for the selection of sensors in our demo sites, we used NetSamo modules, which were very reliable, but we have some problems with Homematic modules because they have large dimensions. They also have low protection, so they disconnect if there are some variations in the supply voltage. And that was a problem, especially with refrigerators in the residential buildings. So we need to take all this into account when selecting sensors in the future. Also, again, for simplicity, it is recommended to have all the sensors from the same provider and they all connected in the same gateway and not to add complexity into the system. For the lesson learned from eTEACHER tools, again, we want to avoid complexity, so a unified IT infrastructure can improve the performance. And as Florian mentioned, in eTEACHER we have different databases for the different countries, and they were transmitting the data to the common database. So if we have an unified IT infrastructure, that will improve all that transmission of data. Also, it is important to store only the data that you need, and for the data structure, creating one table for each type of sensor could be beneficial. Also, we need to have a clear data flow structure from the beginning in order to improve the synchronization and the interoperability of the data between the different systems. And because we are dealing with a big amount of data in this project, we need to design the interface, so we need to show useful information for the users, but not big amounts of data that can overwhelm them and make them disengage. Also, the time needed to load and display data needs to be optimized. For the results we got from the users, we have learned that 94% of users were aware of eTEACHER and 70% have used the app, the eTEACHER app. So the eTEACHER has increased the energy awareness of 86% of the users, and 50 of them has confirmed they have changed their energy use behaviors. Also, they gave us feedback that they don't leave the lights on anymore. They also find useful the information we gave them, and they understand the energy consumption better. And also, some of them, they already knew a lot about energy consumption, but now they give more importance of how they use the energy. So these are very positive results from the project. Also, the users gave us feedback, and that was really important for the project from the beginning, and because the tools need to work for all of them. So some of them told us that there were too many options in the app, or that it should be more user-friendly, or the name has to be changed. So we took all these feedback into account in order to improve the app throughout the project. Finally, we got the feedback that 84% of the users will recommend eTEACHER, and 85% might continue using eTEACHER in the future. For the data we are currently analyzing and will be published very soon, we found at the moment that for some buildings at some months, we can have an energy saving up to 55%, which is really good. And with no significant impact of indoor environment quality, which means that actually temperature, relative humidity, or CO2 concentrations are similar before and after eTEACHER. So the energy saving doesn't compromise the comfort, which was one of the objectives of the project. Also, the most accepted target behavior was reducing the thermostat temperature for heating when it is too hot inside. And finally, for the conclusions, so as I said already, simplicity is key. So we need to reduce the number of sensors and use the same provider when we can, only store the data that you need, and try to have a unified IT infrastructure. Consider data quality for the very beginning to implement data cleansing algorithms within the tools, and also inform and engage users from the beginning and throughout the lifespan of the project. So finally, we can say that eTEACHER results demonstrate that energy savings and behavioral change is possible using ICT. So that was my presentation, and if you have questions, we can answer at the end. Thank you.
So thank you, Carmina. It was a very nice presentation and a very nice closing of what we have learned and our suggestion for following similar approaches. So now we go again to the poll. So I think Veronica is going to share the poll again.
Yes, I'm going to let me know if you can see the results.
Okay. Yes.
I guess people can see results. So do you know, Amy, you can see the results or you cannot?
Yes, I can see them now. Before I couldn't, and now I can.
Great.
Okay. Okay, so regarding this question, apparently the main social challenge to overcome, when we want to enhance a behavioral change is mostly the lack of motivation. And so that's a difficult challenge to, that is something then that we can do with a better user engagement approach. And also another relevant subject is that there are many ICT tools competing for the user attention. Okay, so So maybe, yeah. Okay.
We can move to the second maybe
Okay,
poll, and then we can comment both. Okay.
Yes.
Here we are.
Yeah, and then the second question, which was, what are the main ICT-related challenges to overcome to enhance energy efficiency and indoor environment quality in buildings? And in that regard, 50% thought that the main challenge is technical interoperability, which is 50% of the people. Then we have a draw between data quality, 70%, sensor maintenance, 17%, and low readiness level of the technology, also 70%. And nobody apparently is worried about the local solution. So I think we all think, all the people answering think that there are local solutions in the market. So yeah, I think this is a good starting point for the roundtable, probably. So okay. Then I would like to open the roundtable discussion. And so first, I would like to ask the different, our sister project, what is their opinion on these two questions, on the result of the poll. So maybe if I go one by one, is that the, okay. So maybe Simona, any comment in relation to these issues?
Sorry, Naomi. Can you repeat the question? Because I lost you for a second.
Yes. So the idea was firstly to comment on the result of the poll. So I don't know if you remember it.
Yeah. Can you share the results of the poll again?
Yeah, maybe you can.
Okay, yes, I can. I can try to reshare.
Can you show the two questions at the same time, Veronica?
Well, unfortunately not, just one by one.
Okay, so we will go to the first one and just a very quick answer, Simona, just
sure.
Yeah, just a very quick runner of the sister project in relation to the first one, which is now I cannot see it, Veronica.
Well, yes, actually, it's not possible to show them again. I mean, it was one shot.
No worries. I can read it. So the question was, what are the main social challenges to overcome to enhance behavioral change regarding energy use in buildings? And we have 80% of the audience thought that the main challenge to overcome was the lack of motivation, 83%. And then 17% thought that we have too many IC tools competing for user attention. So my question to you, Simona, is from the perspective of your AAA Reno, which is in an advanced stage. And also if you have any comment from NRG to peers, is it what you have found? I mean, is it for you very hard to overcome the lack of end user motivation? Or is it, I mean, do you agree with this opinion from the audience? So as I say, mostly lack of motivation and too many ICT tools competing for the same end user attention.
Yeah, absolutely. I think these are very much aligned with what we found as well. So indeed, lack of motivation, especially also fatigue in using these tools over the long term. Okay, perfect. Now we can see it. Yes. Absolutely. So I can say that also from our side, these could be the two main issues. So indeed, with the gamified features that I also saw that were elements that we try to include. these we're trying to overcome this lack of motivation from the user side, and also the fact that there are so many ICT tools that are competing for user attention from different sources. It's always a challenge to be the one that stand out, but at the same time, the effort of having a common platform with simplified user interfaces is probably the way to go. So that was my quick answer.
Thank you, Simona. So Philippos from Natch, what is your opinion on these issues? Is it for your project the lack of motivation an issue, and also the existence of too many ICT tools doing mostly the same or competing for users' attention?
Yes, thank you. First of all, okay, you can hear me. I want to mention a couple of things based on these two. I mean, they're very well identified. In regards to ICT tools, yes, in general, when we create dashboards and apps, as we're doing in Nudge, we aim to do them to make them as simple as possible. So very few screens on an app, big buttons, easy graphics, simplified things. So that's on ICT. And when we go for lack of motivation, yes, and I think this can be further disaggregated a bit. So, like which psychological theories have been used there, I'm not entirely sure. In Nudge, we use, for example, theory of planned behavior. And also we make use of certain nudges in order to actually motivate people based on their psychological profiling. So if we see that someone is more caring about their impact in the environment, we will offer an image that shows their impact. If someone is motivated more by what the neighbor does, then we will tailor the intervention based on those factors. So the aspect of profiling is also quite useful there. That being said, I think privacy is also very important because we see that oftentimes certain users will not want to engage because of privacy concerns. So yeah, this ones.
Yeah. Okay, so yeah, mostly we also agree with you from the teacher perspective. Also, privacy was an issue, especially in the residential. And so, any comment, Philippe? What is your point of view in relation? I mean, what is your experience from the feedback project?
Hello. We have a similar experience from the project. These are the two main issues. So privacy was not an issue in feedback. People asked some questions, but we had a detailed documentation explaining which data would be collected and how it will be used. So according to GDPR, so everything was fine in this topic. But what we felt was the main issue was the lack of motivation, indeed. And we also use the theory of planned behavior. But the main outcome or lesson learned, at least from feedback, was that we felt there was an initial barrier to overcome regarding the engagement of the users. But once we were able to overcome that first barrier, they start learning and interacting with the application. And majority of the users that passed initial stages, they went through the end, so they did everything. So I think this was something that I was not expecting. I was expecting that some users lose interest during the game, but we had several levels, so 14 or 15, and majority of the users that passed the first 3, they finished all the levels. So I don't know quite well how to synthesize this information, but this was one of the major lessons that at least I learned in the project, because it's really difficult to engage them in the beginning. So a lot of users only made the registration and they passed the first level, and that was it. So they quit. But those that reach level 3, so they did everything till the end. So this is, I think, the most important data from or information from that we got from feedback.
Okay, thank you, Philippe. So now, Jared, can you give us the point of view of the eBalance Plus?
Yes, of course. I have to say that I'm not surprised by these results of this poll. It is aligned with our experience from eBalance Plus, especially, but also with previous project I worked previously. I have the feeling that at this moment, we as researchers are developing the solutions for enhancing engagement, but there is the barrier is even deeper. For example, when the base is the intrinsic motivation. For example, if the user wants to learn German language, for example, and starting using the application, this application could have some functionalities like gamification and encouraging him to do this in a more frequent way, and can enhance this motivation. But in fact, we need this intrinsic motivation at the start, and I think that it is we have the knowledge, and we have the eTEACHER project is a very beautiful example how to do engaging application. But the question is how to encourage people to pay attention to this application, to install this, and being engaged by it, because there is so many things which compete for users' attention and so on. So we in eBalance Plus are looking for a broader context and broader perspective, how to help people to have this intrinsic motivation, which have to be the starting point, because without this intrinsic motivation, we have the situation that Felipe told, that after some weeks there is a engagement burnout, and people doing something else. They have installed the application, but they don't use it. So in my opinion, we have to seek the solutions which will go deeper to making this intrinsic motivation to use our application and our ICT solutions. That's my opinion.
Okay, and just in relation to this, I will share the point of view of the eTEACHER project. I also agree that the lack of motivation is an issue, and for that, the engagement methodology that we have used has been very relevant. I mean, we have been analyzing we have been getting feedback from the users since the very beginning, and that has been a very hard job. And during a time, in our project, we need to ask for a suspension of 3 months during the pandemic, because the buildings were not used, and so we couldn't get, I mean, we weren't getting any results. And then when we restart, it was hard, because people has a little bit forgotten about us, and so we make a plan with weekly emails and weekly events, and we try to design nice postcard and nice information about the project, and that was an issue, and that is something difficult, because when you, I mean, we need to engage the user, and mostly we have the user in the pilots that we have, and sometimes it's difficult to motivate them. So that was an issue. And also from our perspective, also probably they are a little bit tired of too many tools. And one of the things that we have learned is that we need to keep it simple. That is something that Carmina mentioned. And so that was also relevant for us. So maybe we can go to the second question in the poll, which was I don't know if Veronica you can show it. If not, in any case, I will read it.
It's on the screen. I think that people can see. Probably you as the main presenter cannot see it.
Okay, so that's my luck. Okay, so so the question is, what are currently the main technical challenges to overcome regarding ICT tool to enhance energy efficiency and indoor environmental quality in buildings? And so, as you see, 50% of the audience thought it was system interoperability. And then people also think that data quality, sensor maintenance, and low readiness level of the technology are also an issue, and all of them share 17% of votes. So maybe this time we will go the other way around. So maybe we can start with the eBalance Plus perspective. So Jarek, any comment in relation to this?
I think that I am not a technical person, I'm a social researcher, so it will be only my perspective. I don't know exactly if my colleagues, all of my colleagues, share my opinion. But from my perspective, the system interoperability is really an issue. It also was present in our interviews with the facility managers who are in the whole process. It means that there are so many different standards and different specifications that making them together is not easy. And another option is that there are some technical interfaces between different systems, and there is also always a risk. It is connected with the problem of data of privacy, yeah, and about data and exchanging, because sharing the information between different systems means that there are some gateways, and there is always a risk for the data of being stolen, of being hacked, or something like this. So from my perspective, yes, system interoperability is an issue, and it is of course also connected with some other areas in the project.
Okay, maybe Jacobo, who is the project coordinator of eBalance Plus from CEMOSA, maybe Jacobo, you want to mention something also in this regard? Or maybe you just need to agree.
Okay, I think that Jarek has explained perfectly the solution to address the interoperability that we are developing in the project is because this is the main challenge identified. Yes, this is the main point, the interoperability, and there are solutions that he has mentioned, like the interfaces between different devices and applications that we are developing to address this challenge.
Okay, thank you, Jacobo. So Felipe, what is your point of view from Feedback project? Have you also found this challenge?
Yes. Initially, we planned to buy the sensors for comfort and indoor air quality monitoring, and the problem is that there were a lot of different options in the market, like you have there in the fourth option, low-cost solutions. But the problem was interoperability. They were usually they were programmed to send the data to a proprietary database, and to have access. They were cheap, but to have access to the data in the database, you'd have to pay an amount of money per month for each sensor. So when we did all the calculations, we saw it was impossible with the budget of the project to have a monitoring system as we wanted and as we needed with solutions like that. And that's the reason why we decided to use the money that we had to buy the sensors. We use it to develop one, let's say, tailor-made sensor for feedback. Of course, we designed the sensor with no interoperability issues. So it was designed in a way to send the database to send the information to any database that you want. So we sent everything to the project's database, and we had no more interoperability issues. Okay, the data quality was okay. We have some data cleansing mechanisms, algorithms, if you want to cleanse the data and to have the data that we need. The only issue is the sensor maintenance, because it was designed to work with a battery, and you need to replace it. You also have the possibility of plugging it to a plug, but in many of the buildings there weren't plugs available, so we had to use the battery, and the battery has capacity for a couple of months or less than that, 1 month and a half. And in a lot of many of the buildings, of the public buildings, it was very difficult to make this maintenance. So to go to the sensor and change the battery, because the partners didn't have people available to do it. Also in the residential sector, we also provided these sensors to the house owners. And some of them, they replaced the battery, and some of them were careful enough to plug it to a plug. But I would say that around half, so they did nothing. So the battery ended, and we stopped receiving data. We contacted some of them, but the results were not as we wanted. Okay, so from the feedback perspective, this is what happened.
Okay, Filipos, and the point of view of the NATS project?
I was muted. Right, so first of all, I have to say that this is very beneficial to us, because this is what we will encounter in the coming months. The first thing we have paid a lot of attention to is interoperability. So that is really important for us in terms of the smart meters, the software used, how they're connected to the central platform, or if we need to take data from elsewhere to have the budget to really pay for it. So indeed, we have identified this as a very important issue. And we also foresee risks with sensors, because it's very often that, often some sensors will just drop out of view, or they will stop transmitting, and so on. So these are the two major items we have focused so far, and we've done it in a way that all the information is centralized and we can quickly see it. Now, in terms of data quality, I cannot really speak on this yet, because we haven't managed to collect data yet. This will start of September in March. And I would also finally agree that low-cost solutions are indeed available. So, I mean, we have gotten smart meters for 50 euros or so. So it's quite possible to have the necessary material. So that's it. That's it on that. I hope I can have some more information on the technical in a few months.
Yes. Okay. Okay. And Simona, can you let us know about the two projects you represent here, the AAA Reno and Energy2Peers, please?
Yes, indeed. Well, it is also very beneficial from our side, because somehow it is giving us the certainty that we were not the only one encountering these problems. As I mentioned during my presentation for AAA Reno, we asked for 6 months extension, and that was because despite the fact the individual components of our platform were, let's say, 90% ready or are 90% ready, the integration of these two is still like ongoing as a task. So also the systems of interoperability was for us one of the biggest challenge. And again, I'm not an ICT expert, but as coordinator, we've learned all the details of what is going on and what were the main challenges. So yeah, indeed, I can totally resonate with this, with these shares. And yeah, for energy to peers, we have there, I think we have a different angle because we are, well, differently, we're at a very early stage, but we have two companies that will be working together for the development of the peer-to-peer platform. And there we have two market competitors, and they voluntarily decided to join the project to overcome systems of interoperability outside the Horizon 2020 world. So they really found the fertile ground to see what the other company was doing, the type of protocol use, and the type of algorithms, and try to integrate. So if from one side is a challenge, from the other side it also fueled for overcoming the barrier itself.
Okay, thank you, Simona. I think that, I mean, from the eTEACHER perspective, those were the issues that we have found as we have been presented. And so I won't go into that because I think we're a little bit late. And so I think we should start the question and answer section to allow to, I mean, just to answer to the question that we have been receiving in the chat. So first, I have a question for Jacobo. It is a question, I mean, it is a double question. So firstly, from the challenge you have presented in the integration methodology, the question is which ones are the more critical and how you have tackled them? And the second question asks specifically on the first challenge, which is all these buildings are different. So can you explain in general which challenges were more critical, and then also specify a little bit about the first one, about the all buildings are different?
Well, thank you. From the beginning of at the beginning of the project, the challenge was based on defining a consistent baseline that was also mainly fixed, applying the methodology to define the control group and the study room. This solved many issues that usually we found when we try to define this baseline with regression model or other mathematical approaches. So this challenge was more or less addressed. After that, I think that the most relevant challenge is something that we have been discussing in the different pools today. This is the interoperability with the existing system and the different energy system at building, because sometimes these facilities present the sensors or different ICT solutions to gather data and to control the different devices that sometimes is not compatible or require to apply development in order to integrate these new solutions with the existing ones. And regarding the challenge number one, that all the buildings are different, is closely related with this. When we address different buildings, we can find different energy sources, different equipment that provide heating, cooling, or electricity or comfort conditions in the buildings. And the challenge here is to identify the energy behavior. So we need to monitor, to gather the information from these systems, and we need to design a monitoring system in order to get this information to feed the data to the new solutions that we are trying to develop. And for example, we can find for the HVAC system solution based on electricity that somehow are easier than other to monitor just with a power analyzer or smart meters. We can gather this information. But in other cases, we find other heating system based on gas or heat water or chiller or cool water in which we need to develop or to deploy more sensors in order to quantify the energy. So this is the main challenge in which we need to identify the systems and at the same time how the people are using these systems. So this is the reason why we, in the preliminary stage of the project, we need to adapt our typical template that are used for energy audit to identify the potential interventions to improve the energy efficiency in order to include the variety of facilities that we can find in different buildings. In this project, we have the opportunity to address 12 different buildings, so this is fine, but at the same time is complex. And on the other side, to identify how people are using the system. So for example, in some cases, we find that a tamper-proof system in order to avoid that people use the set point of the HVAC, or for example, we find that some electric panel don't allow us to monitor separately lighting from the HVAC or from other systems. So this kind of issues is what complicates the analysis and the potential design of a cheaper monitoring system, and that deals to increase the budget of the monitoring system, what at the end is not suitable. So more or less, all these things related with the complexity of the buildings and the variety of the system and the variety of the facilities is what we have addressed in the project.
Okay, thank you, Jacobo. I also have another question for Carmina from the chat. So the question is, Carmina, can you elaborate on the possible reason for no impact in the IEQ results? I mean, in the indoor environment condition quality.
Yes, thanks, Naomi. Well, we're still analyzing the data, and that is what I found at the moment. There are really small variations, and for me, the reason is because we are trying to save energy, but we cannot impact on the indoor conditions, as like the lighting needs to be enough for people, to work or to live in their homes. And so some of the recommendations are, if there is enough light outside, you can, open the blinds and turn off the lights inside and use natural light. So for that, you will save energy, but there is no impact on the indoor environmental quality relating to lighting. Also, you can, the thermostats was one of the behaviors that were most affected. Sometimes we turn to overheat. For overheating, we consider the temperature inside the buildings in winter shouldn't be higher than 21 degrees. So by just switching the thermostat 1 degree down, so to 20 degrees, the indoor temperature should be comfortable, and you're saving energy as well. So for those reasons, we can keep the indoor environmental quality, and we can save energy at the same time. So I hope I explained it correctly.
Okay, thank you, Carmina. I also have another question for Alina and maybe for all the tools. And the question is, are all the tools exchanging information between each other? And to what degree they can be exploited separately, or they need to talk to each other?
Yes, so the idea is to show that the information from the building automation system and the information that's coming from the end users can be integrated together. even if they can also function separately. And through the virtual building or the digital twin, we show that it can be the interface that integrates all this information better than other systems.
Okay, thank you. And I think that, well, I have two tiny questions. I don't know if it is a little bit late. Maybe I have a question for the what if analysis. And the question is just very quickly, Hervé, if you can let us know if it would be easy to implement the system for a different building. I mean, what is the cost of the what if analysis each time that you need to go to a different building? Is it very general or not?
Well, for installing so for setting up and starting the what if analysis in another building, that should be in fact quite straightforward. So the only dependency we have is the monitoring system in the building. So this means that if a new building doesn't have enough sensor data or meter data to be used, then it should be installed, and the eTEACHER monitoring system should be set up. So this means some hardware installation and database setup. And as soon as this is done, in fact, the what if analysis itself, it's a tool which is conceived to be self-configuring and so automatically runs on the basis of the eTEACHER database and the monitoring system. So that should go quite quickly to run it on a new building. And well, about the cost of usage, I think this is yeah, beside for one part the monitoring system, like I said, the hardware installations is one part, and then the software part, the maintenance part of the tool. This is another aspect that we do not have clear visibility about for now, which is discussion among the consortium.
Okay, so thank you, Hervé. And I also have a quick question for Nicolas, and it is how did you make sure that, I mean, how have you been dealing with privacy issue? How can you make sure that, for example, in the case of residential, one building, one apartment does not see what is happening in the other apartment, or that the different buildings, the 12 pilot do not see each other?
In general, we had a tool in the backend which was signing the location which you wanted to add, but what actually is the ID of the building and so on was before worked on in the client. That means nowhere in time the server actually knew what client it was, but nevertheless the server had to actually assign, and so we could make sure that you actually knew exactly what to add, and you couldn't add any other room instead. So yeah.
Okay.
And we just provided the data with QR codes to actually that people can scan in the app the data and don't have to put in a huge amount of data to actually get it. They could just use the QR code to actually add those rooms later on.
Okay, so thank you, Nicolas. I think we have covered all the issues and all the questions. And thank you very much to everyone for being here today. I think it has been very interesting, and I have been happy to share with the audience what we have found in the eTEACHER project, and also to see the synergy with our sister projects. I apologize for the delay. We have spent half an hour more than planned, and I'm so sorry for that, but I think it was worthy, and I think we have reached to an interesting discussion. So thank you, everyone. Apologies for the delay, and please, I mean, you can you will be able to have the presentation that we have shared, our presentation from eTEACHER and also from the sister project, and you will also have the recording available so that you can share with us, with your stakeholders. And we are here. I mean, you have our contact information, and we will be very happy to further discuss about anything that you can think about. So thank you very much. Have a nice day.
Thank you very much. It was very interesting experience to be here.
Okay.
Thank you.
Thank you.
Thank you very much for the invitation.
Thank you. Bye.
Okay, thank you. Bye.
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 Thank you.